Thank you very much. This is the real me. Well, this isn't. Basically, I'm old. I remember Java 1.0. I actually used it. I started out my sort of journey into AppSec as a bog standard software developer. I had several stints at several boring things, and about a few years ago, I moved into application security. But over the course of my sort of career, I've had lots of different hats, because you end up having to know everything in order to know something. I generally go off on tangents when I talk, so please stop me. And I've never done a lightning talk before. I tend to ramble on quite a bit. I try not to do that here. So in this talk, I want to talk about denial of service attacks, but not the distributed ones that we've all grown so familiar with, where some bad actor throws terabytes of traffic against some unsuspecting server. I'd rather talk about precision strikes over sort of hard performing. And I'm going to use an example from the Play framework. And I'm going to talk about how these kinds of attacks can be automatically amplified and what we can do about it. So to start off with, like I said, it's small targeted attacks. We want a precision strike. We don't want to have lots and lots and lots of packets hitting some sort of DDoS protection that never gets through. Obviously, low orbit ion cannons is the in-joke there. Right. So what I've sort of looked at is, well, what does infrastructure look like? So when your typical user goes and wants to talk to an application, they would typically go through a content delivery network, they would go through a web application firewall, then it'll hit a number of proxies, load balancers, and then at some point you sort of hit the application which has got some database. And along the way, in any sort of modern infrastructure, you have got protections built in. So the CDN will protect against DDoS, the WAF will protect against lots of different attacks, and then once it all gets through the load balancer, you get through to the application. So the analogy that I've sort of drawn here is the attack on the Death Star. Like I sort of said previously, a fleet of Imperial Star Destroyers is not going to do much good. You need a small targeted munition in order to get there, so you effectively need to find that trench before you use the force. So what I want to focus on here is a specific vulnerability that, blowing my own trumpet, I found. And it's in the Play framework. And I'm not going to read out all this text, but essentially what we found is that you can send a payload of JSON. This is valid JSON, which is just an array nested inside an array, nested inside an array. And if you continue that to somewhere out in the theatre, you get something that with Play causes an out-of-memory exception. It basically blows up the application, and the application then quits with this lovely error message saying, because you've not set a particular configuration, I'm just going to die. Which usually is actually the thing that you want, because when things go wrong and you run out of memory, the best thing is to stop and something else than to restart the thing. Because as we all know in software engineering, the only thing that we ever do to fix things is to turn them off and on again. So this then leads me to this idea of automatically amplifying an attack. So if I submit this payload, these lots of square brackets, and it then hits the load balancer will send the payload off to the first application instance. The application instance will, moving into the picture, which is The payload is hitting that first application instance. It dies, sends back usually a HTTP 503, which means to indicate something went wrong, I'm not there. And what typically happens in any good infrastructure is the load balancer will look at that and go, oh, something went wrong, the application isn't there, so I better send it off to another instance, which then dies again, because that's the nature of the attack, and then it retries. And typically, what I've seen in instances like that is the load balancer might retry 3 times. So one single request can kill 3 instances. And that's what I sort of mean by automatic amplification. Now, what will save us? The first sort of thought was, well, we've got our infrastructure, we've got self-healing stuff, we've got auto-scaling groups, we automatically restart our things. We're no longer living in a place where an application is manually started by somebody logging into the system and booting up an application as a sequence of 10 steps. Well, I hope we're not there anymore. In reality, we all probably still deal with some legacy systems where that is exactly what happens. But anyway, let's assume that we're somewhere in the nice cloud and we've got self-healing and auto-scaling groups and automatic restarts. And there's me sitting with a line of bash that just sends the same request every 10 seconds. Because typically, our infrastructure, when it retries and it sort of self-heals and restarts all these things, they're not back instantly. It takes a while for these things to come up. And if I can just sit there with 50 requests, and that would effectively kill 150 instances, I can sit there and bring down a site quite easily. And the beauty of this is the web application firewall that we typically have in front of our infrastructure will not save us either, because they're good against abnormal requests. If somebody sends you a request with the log4shell payload, the WAF will go, that's a log4shell payload, I'm not going to allow that. The payload that I was describing here is different, not because it's different, but because typically the WAFs only inspect the first 8 kilobytes or 16 kilobytes of a message. And if I put 16,000 spaces at the front of my payloads, then the WAF has got nothing to inspect. And it will hit the load balancer, who then faithfully will forward it on. I mean, this works because Play by default accepts payloads that are 100 kilobytes in size. But those angle brackets that are going over to the lecture theatre, they don't need the 100 kilobytes. So the WAF won't save us, but surely a bit of dependency analysis, some vulnerability thing will save us, because as I've said before, we've identified this particular vulnerability, we've looked at it, it's got a CVE, it's in all the vulnerability databases, so any of those lovely software component analysis tools will identify that, we're using Play. But interestingly, the score of that is only a 7.5, which, as it happens, is the maximum CVSS score that you can get for something that's just a denial of service. Unless it's something like a sexy remote code execution, you won't find more than 7.5. And I've seen lots of vendor presentations where they go, this tool is great, and you can set your policies, and any scores that are higher than 8 will automatically block you. And what that means is that when you only have got a score of 7.5, you might not actually catch that, or you might think, I've gone and blocked all the vulnerabilities. So you really have to sort of check all the CVEs for potential impacts. And this is just an example. There's a whole class of vulnerabilities where if you use regular expressions to validate some data, it's very easy to do that in your own code. The developer says, right, I just want to verify this pattern. but you then can craft strings, if they're quite long, that then cause something to just eat the CPU and sit there for 10 minutes spinning, and that's effectively going to be the same as killing an instance. So there's lots of vulnerabilities that SCA tooling will not actually help us with. So how far along? Well, not that long. Anyway, so the lessons that I wanted to sort of take away from this is to take denial of service vulnerability seriously, because if you imagine that you're running a website, you're some government organisation, what have you, and somebody comes along and starts sending 50 requests at a time over the course of half an hour, and your instances just starts dropping out, and every time a new one comes up, a new request hits it, and it blows up again. What can you do against that? I think the best thing is to sort of just be aware of what could happen. Be aware that any vulnerability that comes in through one of your libraries might contain something like that, because something could be classed as a CVE of 5, and you sort of look at the CVSS score of 5, and you look at it and say, that's 5, it's not going to affect me. Yeah. And really, in order to be able to find these things, you have to have the right observability in your system to sort of see what went on. If you just see a graph of instances dropping down, and you're not really sure what kind of payloads are being sent, somewhere you have to look at. And as with anything in security, the best thing to do is have some layered defenses. I'm not saying that the CDNs or WAFs or all these things are useless. They serve a purpose, but it's sort of like a Swiss cheese model where there's ways through everything. And I thought this was an interesting sort of topic, which hopefully will give us some thoughts. So that's it. I'm not sure how long I was on this, so hopefully short and sweet. So I've never done a live talk before. And I blog about this stuff if you're interested. Any questions? Yes.
What's the kind of protection or the mechanism we can use in operations, I guess, to sort of highlight that this is occurring, but also to resolve it without necessarily having the underlying fix available?
Well, I think one of the things to look at is somebody needs an overall understanding of what things do. If this play service, for example, is used as a sort of front-end service that just serves out form-based posts and HTML, does it have to be able to accept a JSON content type? And one of the reasons why this is an interesting vulnerability is because even if you're just using form-based HTTP requests, you can actually send JSON to the same endpoint in Play, and Play will try to convert it into a form-based thing and fall over in the process, or reduce it if this vulnerability has been patched. And we all patch everything to all the latest versions all the time, right? No, we don't. I think the thing really is to have some sort of program where you can look at the security of your system as an overall thing, and that means probably somebody will have to evaluate every one of the CVEs that your vulnerability scanners bring, and you've got one, right? Yeah, everyone does. Is that all right?
Yeah.
Anything else? Yes.
Do you have any particular go-to tools or resources for being able to actually identify these vulnerabilities and better scanners and better payloads, things like that?
I mean, the best, one of my favourite tools, I'm going to use my BBC voice here, other tools are available as child proxy. just a box standard web proxy or burp suite or something like that to inspect what's going on and just curl to sort of try hitting things and playing with them. I mean, this vulnerability we found because we're playing around with something else, and for some reason I just thought, well, what happens if there's a nested thing that just created a huge amount of angle brackets and something happened. I think it's the problem with sort of finding issues. A lot of it is luck, a lot of it is coincidence, a lot of it is finding something in logs that looks a bit strange, and then sort of scratching that itch and pulling on that string and running out of cliches. But that's why I think observability is key, because there's so many things that you don't know where to look at any system of scale. We just have to have that sort of thing they can look back. Can you look back at your logs over the last 2 weeks? Can you look back at payloads that have been sent in? And that then allows you to look at things. But unfortunately, I think ultimately it's a lot of legwork where somebody will have to look at stuff. If you just put in a few automated alerts where you go, if my errors go over 5% of the requests, you're not going to find things like that. Does that make sense? Anything else? No? Well, thank you very much.